In this lesson, we will go through kinetic molecular theory or KMT, which is an important part in the chapter gases. KMT, that is kinetic molecular theory, is a model that explains the properties of an ideal gas. In science, what always comes before why? Why gases behave the way we have observed earlier. Kinetic molecular theory gives explanation in particle level. The word kinetic refers to motion, right? Kinetic energy is the energy an object has because of its motion. So kinetic molecular theory makes assumptions about the size, motion, and energy of gas particles. So KMT has 5 basic assumptions, and substances that obey these assumptions are considered ideal. The particles are so small compared with the distance between them, and that the volume of the individual particle can be assumed to be negligible when you compare to the container size. So I can say the volume of each particle is 0 when we compare to the size of the container. So we assume that according to kinetic molecular theory, gas particles have no volume. That's the first assumption, or we can say that's the first postulate of kinetic molecular theory. The second postulate is that gas particles have elastic collisions. Let's see what is that means. The bottom one is inelastic collision and the top one is elastic collision. So kinetic molecular theory says that the gas particles are always in constant, random, straight line motion. Always it is moving like that. It always moves straight line, not curved path. Always it will move straight, which is represented by an arrow pointing towards some direction. The length of the arrow shows more speed, and if it is longer and if it is shorter, it says lower speed. So that indicates the speed. The length indicates the speed and arrow indicates the direction. There is another postulate of kinetic molecular theory. It's not attracting or repelling each other. The particles will not have any attraction or repulsion to each other. The speed of the gas particle is directly proportional to the kinetic energy, which is directly proportional to the Kelvin temperature. So, which is actually shown by a plot called Maxwell distribution. And here the graph illustrates the particle speed and fraction of particles. The fraction of particles on y-axis and the speed on the x-axis. So as you can see this one here, there is going to be shaded on this side. That means these particles will have more speed. Speed increases this way. So this one shows the molecular speed. See this one, very, very small speed, and speed increases for the red particles. So the fraction of particles with a lower speed very high, fraction of particle with a higher speed is very low, as shown in this red shaded area. So that means the speed directly proportional to the kinetic energy, which is directly proportional to the temperature in Kelvin scale. This graph shows the particles with a temperature 273 Kelvin, and here the red graph shows particles with a higher temperature, and the black one shows even higher temperature. So this is the highest temperature here. So we can see that more particles are with a higher speed. In this case, less. And in this case, the least particles with the high speed. So this is the lower speed, maximum particles here at 273, and at 1273 Kelvin, we have more particles with a higher speed, and even 2273 Kelvin, we can see even more particles with a higher speed. This is an example of Maxwell distribution at different temperature. So when the temperature increases, you can see the plot is getting flatter. That shows more particles with a high speed. Here is a question to check your understanding of the concept we just discussed, which is kinetic energy is directly proportional to the temperature in Kelvin scale. So this question says, the questions below refer to the cylinders of gas shown here, nitrogen, helium, and argon, all at 295 Kelvin with the same volume and pressure. So which gas has the greatest velocity? So we know the formula for kinetic energy is Ke equal half mv squared. So based on that, which one will have the greatest velocity? The mass will be different. Look the mass in the periodic table and see which one will have the greatest velocity to keep the kinetic energy same, because the temperature is not changing. So the kinetic energy for each one will be same. So look in the periodic table and see which gas will have the greatest speed or velocity. And then the next question is, assuming the mass of the empty cylinders is the same, which cylinder would have the greatest mass? Justify your answer. So again, you can look in your periodic table and see which one will have the greatest mass. And this, which gas has the greatest kinetic energy? Justify your answer. So this is the one I'm looking in your discussion board question. Okay, so come up with the answers and check A and B in the next slide and come up with your own answer for this one and share it with your peers in discussion board. So the answers for question A and B is explained here. So you have to explain like this for this one. You answer the question and justify. Okay. So the first question, helium is the answer. The reason is the formula is Ke equal half mv square. Since temperature is constant, average kinetic energy is constant. Therefore, as mass decreases, velocity increases to maintain the constant kinetic energy. And the second question, assuming the mass of the empty cylinder is same, which cylinder would have the greatest mass? Justify your answer. Argon, assuming same temperature, volume, and pressure, they all have the same moles. Since argon has the greatest molar mass, it would have the largest mass. So which gas has the greatest kinetic energy? And justify your answer. Okay, go ahead and explain in the discussion board. Thank you.